Okay, so let's finish up here. So we have the parametric equation x equals t squared plus t minus 3, y equals t minus 3. Let's take a look at what that looks like with our calculator. So let's clear out everything else that we have. And I have the work and the answer of converting it into a Cartesian equation. I'll go through that in a second, but let's go up here. So x equals t squared plus t minus 3, and y is just t minus 3. And again, I have t's running from negative 10 to 10. There's no trig involved, so I think it's a good idea to go from negative 10 to 10, get some positive and negative values, and have the step size being 0.1. We might want to change, for now, let's set the axis back to negative 10 to 10, the standard window, by 1s, and the y-axis is set to that. So there we go. This thing winds up being a quadratic with x turned in toward the x-axis instead of the y-axis, since the square is on the x variable instead of the y variable. Okay. So back to the question at hand here. Eliminate the parameter to write a Cartesian equation. Well, one way to do that when it can be done is if one of the equations can simply be solved for t, you can do a substitution. Here, this one would be difficult to solve for t, but if y equals t minus 3, we can just add 3 to both sides and get that t is y plus 3. I can then plug that into this equation, and we get x equals, instead of t, y plus 3 squared plus y plus 3 minus 3, which I can multiply all that out, but there's no need to. This is the purpose, is to eliminate t and get an equation which has x and y involved in it. So this parametric equation has this Cartesian equation involving only x and y. Of course, this would be really hard to plot because we would have to solve for y, but we have it in the parametric form, and there we go. We see it's not a function of x. It is, however, y as a function, or x as a function of y turned on its side, and it's a parametric function. Okay, we have a couple more examples. Part B, involving trigonometry. So with trigonometry, it's not so easy. I'm not going to use an inverse trig function and try to solve for t. That's not going to be what we want to do here. It's not as easy to just get t by itself. But what we can do is use some of our properties of how these things relate. If x is secant and y is tangent, well, we have a Pythagorean identity. We know that 1 plus tangent squared is equal to secant squared. And then if tangent is y, then I can just plug that in and get 1 plus y squared. And secant is x, so we get 1 plus y squared equals x squared. Let's take a look at what that would look like if we graphed it, just to see another example. So y equals, clear out the last one, get rid of our parabola. Secant, so we're going to have to do 1 divided by cosine of t. And then we want tangent of t. Okay, I'm going to go and I'm going to change the window. Now we're doing trigonometry. We'll run through the complete period of these things if we go from 0 to 2 pi, which I can type in the 2 pi, and when I hit enter, it's going to convert it to a decimal. Graph this thing. Oh, I typed them in the wrong spot. If we were in class, you could have caught that and told me. Let's see, cosine t, parentheses, tangent t, clear this out. Here we go. We're going to get what we call a hyperbola. It's this curve. These are actually asymptotes that it winds up connecting the points, and you really just get this curve and this curve. So you get some really neat looking graphs if you throw in parametric equations. But again, the question was to eliminate the parameter t and come up with a Cartesian equation. In this case, we went to the Pythagorean identity and then substituted in and got 1 plus y squared equals x squared, which is a conic section. You get a hyperbola. Okay, one more example in our notes. We've got one, x is cosine t plus 1, y equals secant t. Kind of like the last one, we've got trigonometry, so we can't just solve for t easily. But let's see how they relate. Cosine is 1 over secant, so x is 1 over secant of t plus 1. And then secant is y, so x equals 1 over y plus 1. So if you have trigonometry, look for some sort of identity that relates these things, and then substitute in what x or y equals to until you come up with an equation that doesn't involve t. And you don't have to solve for y, you just have to have an equation involving only x and y. Here we get x equals 1 over y plus 1. Well, again, for more practice on how to graph these things, let me go to the calculator and see what this looks like. So x is going to be cosine t plus 1. And then we're going to let y be secant t. So that's 1 divided by cosine of t on our calculator. We just graphed one that was trig, so the window should be set. There you get, it's a rational function like 1 over x, but we have 1 over y here. But again, these were cosine values, so they were trapped. They don't run from negative infinity to infinity. You only get this small piece. We've got this part going toward the asymptote, this part going toward the asymptote. The graph is actually chopped between 0 and 1. Let me do one last graph just to show you some of the neat looking things we can see here. So if we do cosine of something times t, like say 2t, and then I did sine of 2t, we'd get the unit circle we saw. But if we change and we do different coefficients here, you get some really interesting looking graphs. Let me zoom in on this a little bit. I'll use zoom box. If you choose zoom box, you can set the cursor where you'd like the corner of a box to be. Click enter and drag. I'm using sines and cosines. Everything's trapped between -1 and 1. Let's box around that. And it goes around and it maps out this guy. I can very quickly show you a couple different examples. Let's change this to a 3 and that to a 2. So there you can see you can get some really wild looking graphs with parametric functions. Extremely useful in computer graphics and mapping out things in real life. So hope you enjoyed our little lesson on how to graph parametric functions, how to convert from parametric to Cartesian. Those are the two big skills I want you to be able to do, and there is some web assigned homework to go along with that.